Welcome. My name is Venkat Thanvantri, VP of R&D responsible for artificial intelligence product development here at Cadence. During this video, I will discuss why AI-enabled data analytics are critical to drive the continued growth of the global semiconductor industry by improving engineering team productivity. The semiconductor industry has been experiencing strong growth during the past decade and is well on the way to being a $1 trillion business. The explosion in the new technology like 5G connectivity, artificial intelligence, hyperscale data center computing, and autonomous vehicles has been driving demand for new system-on-chip devices. Unfortunately, the number of highly specialized designers needed to implement all these new system-on-chips has not been growing at the same rate. So engineering teams are now under immense pressure to implement larger chips in less time with the same number of engineers. It is now clear that if the semiconductor industry is to continue growing, engineering teams will have to become increasingly productive so more silicon devices can be completed in less time. The world is on track to generate more data every year, and a whole industry has been created to process and extract value from just a few percent of this data. On a smaller scale, the same trend is seen in system-on-chip development. As design sizes grow, a typical SoC will be implemented using many hierarchical blocks, each block generating large amounts of EDA data during the iterative design process. Some of this information will be reviewed by the engineering teams as the design progresses, but the majority is simply deleted due to create disk space for the next project. To allow SoC products to continue growing in size and complexity, it is essential this valuable EDA data is systematically and efficiently utilized, providing practical information to the engineering teams, enabling faster design closure, and the ability to quickly transfer knowledge between projects. The next era of the silicon design excellence will leverage the vast amount of valuable data generated during SoC designs to deliver better PPA with reduced engineering resources. The Cadence Joint Enterprise Data AI, or JEDAI, platform delivers an open, enterprise-grade, AI-driven, large-scale, cloud-enabled data analytics environment, optimized for vast quantities of EDA data. EDA data covers a wide range of heterogeneous structured and unstructured information, which is not easy to store and process in general-purpose environments. Long gone are the days a design team could import text-based reports into spreadsheets, sort a few columns, and extract some useful information. Cadence JEDAI is a cross-Cadence design, storage, and analytics solution that has been built from the ground up to support EDA-type data such as design data, RTL, netlist, waveforms, workflow data, tools and methodology, workload data, runtime, memory usage, disk space usage, etc. Cadence JEDAI also provides comprehensive application programming interfaces, APIs, and industry-standard scripting tools such as Python, Jupyter Notebook, REST APIs, enabling AI-driven big data analytic applications to be created, allowing engineering teams to visualize data and trends and automatically generate practical design improvement strategies. By using Cadence JEDAI, designers can quickly identify the most critical power, performance, and area objectives and design bottlenecks, resulting in faster design closure with fewer engineering resources. Cadence JEDAI enables a generational shift from single-run, single-engine algorithms in electronics design automation to algorithms that leverage big data and AI to optimize multiple runs of multiple engines across an entire SoC design and verification flow. A great example of how Cadence JEDAI is being used across different products is Cadence Cerebrus Intelligent Chip Explorer, which automates the digital design implementation optimization using reinforcement machine learning and scalable distributed computing, delivering improved PPA more quickly than a manual iterative approach. To enable the reinforcement learning process, Cadence Cerebrus generates a lot of design metrics data and machine learning models, which the Cadence JedAI platform can utilize in various ways. For example, based on the historical Cadence Cerebrus ML model data, Cadence JedAI using AI-driven analytics can predict and generate a customized machine learning model for future designs, significantly reducing the runtime for Cadence Cerebrus to generate an optimized design. These kinds of productivity benefits can only be achieved by integrating big data analytics into the design optimization process. Another good example of how Cadence JedAI is being used is the new Verisium AI-driven verification and debug platform. Verisium is built on the Cadence JedAI, natively integrating the Cadence Xcelium, Jasper, and Palladium verification engines. Using Verisium, all verification data, including waveforms, coverage reports, and log files, are brought together in the Cadence JedAI platform. Verisium machine learning models are built and other proprietary metrics are mined from this data to enable a new class of tools that dramatically improve verification efficiency. Verisium delivers a suite of apps such as Auto Triage, Pin Down, and Wave Miner, leveraging big data and AI to optimize verification workloads, boost coverage, and accelerate root cause analysis of bugs, improving overall verification productivity. By combining Verisium and Cadence JedAI, a new era of AI-driven verification and debug has been enabled. Cadence JedAI is a key element of the Cadence intelligent system design strategy. We look at the world as three concentric circles. The innermost circle is silicon, the next circle is the system, and the circle around that is data, which drives pervasive intelligence. A perfect example of this is an electric car. You have the data used by the car, the physical car, the mechanical, electrical, hardware, and software, and then the silicon that drives the whole system. Cadence JedAI is part of pervasive intelligence, where we use data AI-driven analytics to optimize system and silicon design excellence. With JedAI, Cadence unifies its computational software innovations in data and AI across Verisium AI-driven verification to Cerebrus AI-driven implementation. In turn, this enables customers to use AI-driven optimization and verification to create multiple designs in parallel with fewer engineers. For more information, please visit cadence.com. Thank you.